Hello everyone, this is a video lecture for pre-cal. We're going to be doing 10.6, conics and polar, and what do you think about my handwriting, right? It's always terrible, especially on these titles. It's like a little child is doing this. Oh man. Anyways, if your handwriting's just like mine, then I didn't want to, uh, insult you, but I have to say mine's pretty bad. Okay, conics and polar. What is going on here? Well, conics means ellipses, parabolas, hyperbolas, and all that kind of good stuff. Polar means r and theta. So we're mushing them together. Here we go. R is equal to ED divided by 1 plus or minus E times sine of theta, or R is equal to ED, E times D, and then divided by 1 plus or minus E cosine theta. I kind of made it too small, I feel. That's okay. So cosine and sine are the only difference between these two. What I'm going to do is decode all this stuff here in just a second. But some things that you need to know is that this is always the focus is at the pole. And so what does that mean? What does that look like? Well, let me give you some demonstrations. We have my focus is right here at the pole, and let's do a Y major ellipse. It's going to have a directrix also. I know that it's weird, but ellipses actually do have directrix. Directrixes? I don't know. What about an X major ellipse? Something kind of like this. Again, there's a focus, and then there's the directrix. Now, these distances are not the same. It doesn't just say, oh, well, same distance here, just like a parabola. No, 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 no. Way different situation. There's also another focus right here and right here for these guys. We're not graphing it because it's not a big deal for us. Here's some more examples. So let's say I have a focus at the pole, and let's do a parabola. So it looks something kind of like this. Again, directrix would be right here. This is the only time that this distance here is the same as that distance there. So that's handy, but it's kind of singular, I suppose. And the same thing here, focus at the pole, and then we go whoosh, whoosh, and then there's your directrix there. Cool. There's actually a lot more. I'm going to do two more that I don't have on my notes, and so these are hyperbolas. So this is, again, a focus, always a focus here. And so let's do an X hyperbola. Something kind of like this, okay? The directrix is somewhere between these two, and again, it's not centered. It's not centered, so you can't just rely on something like that. Here's another one. So this is the Y hyperbola. I make them look like parabolas on mistake. They actually should be a little bit more like whoosh, whoosh, but that's fine. Okay, so those are some hyperbolas. Now, how can we tell which one of these is what, right? So let's go back up my formulas for a second here. I got a lot of letters. I'm just going to draw this one for a second. Just know that it could be also a cosine. And so I got R is equal to ED, 1 plus or minus E sine theta. Again, that could also be a cosine. And you know what? I'm going to do it. I'm going to do it because it is an important thing to decode all these things. Once you see the I don't know, the decoding of it, it's so easy, okay? So E is the eccentricity. Eccentricity. I'm not very good at spelling, but I'm way worse at writing. Eccentricity. I'll talk about that more in a second. It's just determining what shape you have. D is the directrix distance. So let me try that again. Directrix distance. Oh man, this tablet's got really tiny. Okay, so that's a directrix distance, which is fine. They might use P. I don't know if they'll use P or not on your homework, but D stands for directrix distance. I mean, it just makes so much more sense to me to use a D. Wow, that is just the worst D now. Let's start over on that D. All right. So that's your E and D. We took care of those. The sine and the cosine theta is just what we have, and there's a 1. So everything else is kind of done for us. Those are the important ones. what we're going to do is decode it. And I'm wondering if I should decode it now or later. Let's do it now. Let's do it now. So the E is going to tell you what shape it is, okay? And that's an easy one. The plus or minus is going to be part of the directrix equation. So here we're going to have a y equals. Here we're going to have an x equals for my directrix stuff. And then my d is actually the directrix value. So in this particular one, I would have y is equal to plus or minus d. And here I have x is equal to plus or minus d for my directrix. These are the directrix equations, I guess you can say. So if you had a plus, you have a plus, a minus, and a minus. Same thing here. So the x and the y changes for sine and cosine. D is going to be your actual distance. And E is kind of its own thing. What's going to happen is that you need to find E first, and then you can like solve for D. That's going to be the main key here. Find your E and then solve for D. So let's talk about eccentricity now, because it's important. There's a lot of topics before we can get started. So this is eccentricity. I'm just going to do ec. So we got eccentricity is equal to 0. What does that look like? It's actually a circle. I'm going to write circle. I'm going to keep going. Eccentricity is less than 1. So if you have a value that's less than 1, it's an ellipse. Ellipse. So not a circle anymore. That kind of doesn't look like an ellipse. Here, I'm just going to do that and then. There you go. More ellipsy now. E equals 1. Once you hit the 1 mark, it's a parabola. Parabola. And then we have E greater than 1 is going to be a hyperbola. And so hyperbolas are going to look more like this here. And again, there's 2 of them. There we go. So it's really a cool like metamorphosis here on this math. You got a circle, and think more like orbits of planets and comets and stuff. Notice a circle, that's like a perfect circle. That's basically like Earth, you know, Earth going around the sun. Our eccentricity is very close to 0. Compare that to, say, like Pluto. Pluto's got a crazy eccentricity because he's like, it's not because he's far out, it's because he's wonky. So like you got the sun, and then you got like Pluto is like, it's not centered on it. But for Earth, we're like right in the middle, which is really nice for us. So yeah, our eccentricity is near 0. Pluto's is like way out there. So Pluto would have an ellipse, or comets even, because like Halley's Comet would like come in and then like whoosh, and it comes in and then leaves again for a long time. So that's an ellipse. Parabola is something that would never come back. So just for example, which kind of doesn't happen in space, say you had a comet that came in hot, and then it said, oh, cool, there's a sun, and then let's leave. And it like never came back. Now, that's also the same with the hyperbola. Oh, I should have wrote that. Hyperbola. But this is more of a linear line, which I guess is kind of true. So the parabola still curves. The hyperbola kind of does like a straight line kind of thing. Anyways, we haven't even done any homework problems, so you can see how I really like this topic, but we just probably ought to just do the homework. So 3 over 1 minus 3 sine of theta, and they say decode it, tell us the shape, directrix, all that kind of stuff, okay? Well, right now I have an eccentricity of 3 because, well, that's what E is, and so this is a hyperbola. Hyperbola. I didn't spell it right. Whatever. So this is ED, but I already have E, so that's 3D is equal to 3, right? So what's D equal to? D is equal to 1. Okay, so that's kind of interesting. So that's your directrix distance. And so I want to find my directrix value, I guess, my line. And so notice that we had a sign, so that's going to be y equals. We had a negative right there, so it's going to be a negative. And that's a 1, so that's a 1. Like, let me even like show you. The sign makes the y, this negative here makes the negative, and the 1 makes the 1. So I'm just pulling pieces from it to find my directrix. And you're done. They wanted that. They also want the graph and something else, but we can do this now. It's a hyperbola with the directrix and y equals -1. So there's your directrix. Focus is always at the pole. So somewhere in there, we got hyperbola going on, and then we'll have, of course, the other side right there. So they ask a question in my math lab, and I don't know if this is every question or just this one. They say, is it parallel or perpendicular? Perpendicular to the polar axis. What? You didn't prepare me for this, Chad. Oh, I know. The answer is parallel. Why? What's going on? Well, the directrix is right here, yeah? And the polar axis is this guy. So these two lines, what are they? Perpendicular or parallel? Exactly. Okay. If that comes up in the future, you know what to do. I'm probably not going to be focusing on that at all. So I've got r is equal to 16 over 6 minus 2 sine theta. Okay. And this is not ready to pull apart. Notice that this is a 6. That should not be there. So what we need to do is we need to divide everything by 6 on both the top and bottom. And this is a legal move. This is okay to do as long as you're doing it for everybody. Everybody gets a divide by 6. And so what you did is multiply by 1/6 over 1/6 if you want to go the technical math way. What this is going to do is create that 1 right there, which is very important for us. This will reduce to 1/3. And what, 8 over 3, I guess? Is that what I got? Yeah, 8 over 3. Okay. So I have this boxed in. I wonder if they actually wanted this as like an answer. I'm going to keep going with it, but I boxed it in. And normally when I box things in, it's like an answer. So they might want that equation, and that's fine. We can definitely do that. So let's pull it apart. So we got 8/3, 1 minus 1/3 sine theta. Okay, so let's start with the directrix. So I got sine is a y. I got 1/3 is e. So that's not going to help me with my directrix. I got a negative sign, so that's going to be a negative. This is ED. But I know what E is. It's a 1/3. And this is 8/3. I wonder what D is. D is equal to 8. So 8. There we go. With that alone, I could graph this thing. And so, ellipse is what this shape is. That's going to be important. So directrix, y equals -8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's your focus. And then we need an ellipse, and it's probably going to do something kind of like this here. It's a y major. Gosh, man, I just made the worst ellipse ever. There we go. That's close enough. Now, just to see more, I have a little thing here. If you wanted to know what that point is, then what you need to do is you need to say, well, theta is equal to 3 pi over 2 right there. Plug it in and find what your r value is. When I did that, I got r is equal to 3.555. And so that's like 1, 2, 3 and a little bit. So it's actually pretty accurate there. So that would be at 3.5 distance from the pole focus thing. I don't know. There you go. But you don't. That's not required. That's just on the side there. Okay. You will have to do it again later, but I'll just do it when we need to do it. We've got a lot of signs. I want to do a cosine one, man. So this is all they give us. My E is equal to 1 because there's an invisible 1 right there, so that's a parabola. Okay. My directrix is y equals from the sign. There's a plus sign right there, and this is E is a 1, so your D's got to be a 2. So there you go. So let's draw this thing. I have y equals positive 2. Focus is at the pole. And because parabolas, you can say, are right in the middle, this is your vertex or your center. I like to say center. And it'll go whoosh whoosh. So there you go. Pretty easy stuff there. So they're wondering where the center is. They say, where's your vertex? Where's your center? And I tried plugging in 0, 1, because that's what that is right there. And they said, no. They said it's 1 comma pi over 2, of course. So they don't want x, y. They want r theta. And that's fine, I guess. So notice it's straight up. Notice it's straight up. So that's pi over 2. And then how much distance did you go? 1. Tiny bit annoying. Okay, I got 2 problems left, and then we're done with this class. Yeah, this is it. So I've got r's equal to 45 divided by 3 minus 15 cosine theta. Oh, finally a cosine. So first off, see the 3? So I have to divide everything by 3. Okay. So that's a 15 in the top. That's a 1, and then that's a 5. So my E is equal to 5, which makes this a hyperbola. This is ED, which is equal to 5 times D is equal to 15. So D must be a 3. And so my directrix, sloppy, is x equals, finally, because of the cosine, negative, because there's a negative sign there, and the 3, because it was a 3 distance. So there you go. So it's a hyperbola with the directrix of this thing. Let's graph it. And I think that's all they need. I don't really know. So there's my focus at the pole, of course. 1, 2, negative 3. Here's my directrix. And so then we need to graph it. Hyperbola stuff. Yeah, it's something like that. Again, what if I had, see how I'm going this way here? What if I had theta equals pi, and what you find, if you did theta equals pi, and you plugged it in, you get r is equal to 1. So it actually is colliding right here at 1 for your vertex, whatever. It's not the center, but that's a vertex for sure. Okay. Oh, it's not 1. I'm sorry, it's 15 over 16, which is about a 1. Okay, well, there you go. Sorry. Well, you know, it's pretty close. You just want to know what graph it is, A, B, C, or D. Okay, last one, 10, 6, 31. This is it, guys. It's the satellite problem. Oh, yay, an application. So 4,088.07 divided by 1 minus 0.0084 cosine theta. And it says, how far is it when it's furthest away? Let's just start with that. So how far away is it when it's furthest away? Well, let's just see that this is a negative directrix. This is definitely an ellipse. And I don't know all the specifics, but there's a focus right here. I have a negative directrix. And so it's going to do something kind of like this. Okay. So how far when furthest away? They're wanting to know, like the focus is the planet or something like that. How far away is this? What's this distance here? Okay. I don't want to say D because we're using D already. And I don't want to use X because it's not really a thing either. Anyways, find that distance. How do we do it? And actually an R. I want to use R because it's technically going to be an R. Well, I'm going to plug in theta equals 0. Like 0 degrees, 0 radians. So like you can see this direction here is 0 radians. So I'm going to plug that 0 in right there. And I'm going to get an R value. And I did that in Desmos. And I got R is equal to 4122.7. I don't know, kilometers, miles, whatever they're asking. Okay, so that was easy. It's pretty easy stuff there. Now, part B says if the planet is a 3510 radius, then how far from the surface? How far from gross the surface? There we go. This is the easiest thing ever. You love like the last thing being super easy. I'm going to take what I had, and I'm simply going to subtract that 3510 because like the planet is like it's got some kind of distance here on it, so it's saying what's this distance here now. So you just subtract. Gosh, man, that is the worst 5, but we're done. So 612.7. There's your answer. We're done. So we're done with pre-calculus. Thank you very much, guys, for hanging out with me. Have a great day.